Hello everyone. Plan for this recording is to talk through some examples. In the recordings I've given, I do a lot of just discussion of what graphing is and how to graph and that kind of stuff. And even on the homework, I don't have a lot of practice problems. So I'm going to do one quick explanation on the first one here and then kind of just throw problems at you. You can hit pause, work out the problem, come back, hear my explanation, and so on. So that's the goal. Pretty short and quick, but just wanted to throw some practice problems at you where you have an explanation when to check your work with. So let's get rolling. So the first thing I have up here is a quadratic. So let's graph probably 4 or 5 quadratics. Then we'll skip to absolute value, and then we'll call it good. Okay, so my parent function I already have graphed. So y equals x squared is what I have graphed. This is what we're going to graph right here and kind of relate it back to my y equals x squared. So that's kind of the thought process we're going to do for a few of them. I'm going to do 2 or 3 one way and then 2 or 3 a different way, and you can pick the way you like. Okay, so if you know what to do, go ahead and just try. Here's y equals x plus 2 parentheses squared. So the x plus 2 is inside the squared minus 1. If you know what to do, get rolling, and I will get rolling also. But go ahead, pause, sorry. Go ahead, pause first, give it a try, come back, and I'll explain. Okay, so hopefully you've hit pause and you're coming back. So here's one way of doing things, okay? This point right here is my vertex. That is the bottom or top, if it's upside down, of my graph. So the question then is, where is the vertex for this graph? And if I want to simply make tables, and I don't want to look at the shifting and all that kind of stuff that I'm going to talk about here in a second, and I just want to make tables, then what I'm going to plug in for x is what makes this 0. Okay? So what makes x plus 2 0? A negative 2. And that will be where my vertex is. That'll be the x coordinate of my vertex. So now I'm just going to move left and right. So if this is my vertex, I want to check points to the left of my vertex so I get this part of the graph. And I want to check points to the right of my vertex so I get this part of my graph. If I just simply pick random points, this graph may be sitting way down here. So like if I were to just throw a graph down here, and if I were to plug in only points like -1, -2, 0, 1, 2, I'm going to get my graph that's way up here, and I'll never find the vertex. And I'll have no idea what this thing looks like. So I really do need to pick points that start with or are centered around the value that makes this 0, which is the value, x value of my vertex. Okay, so working to the left, excuse me, working to the left, I get -1 and 0. Working to the, oh, sorry, wrong way. Working to the left, I get -3 and -4. Working to the right, I get -1 and 0. Numbers that are smaller, numbers that are bigger. Now I'm just going to plug them in. -2 plus 2 is 0. Squared is 0. Minus 1 is -1. Plug in -3. -3 plus 2 is a -1. -1 squared is a +1, right? -1 times a -1. Minus 1 is 0. When x is a -4, a -4 plus 2 is a -2. Wow, excuse me. A -2 squared is 4 plus or minus 1 is 3. Now notice the symmetry over here. Let's just show that it does show up again over here, and then the next time I make a table, I'm just going to use that symmetry. Put a -1 in. -1 plus 2 is a +1. A +1 squared is a +1. Minus 1 is 0. Notice the symmetry. 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. Just like this has symmetry, this also has symmetry. So when I'm going to start my vertex first. When x is a negative 2, y is a negative 1. When x is a negative 1, y is 0. When x is a negative 3, y is 0. When x is 0, y is 1, 2, 3. And when x is a negative 4, y is also 3. And I get the exact same graph shifted down and over. And we're going to talk about this later, but shifted left 2 and down 1. Okay, let's try another one. Y equals x minus 3 squared. All right, make a table if you want. Sketch graph. Hit pause, come back when you're done. All right, hopefully you've had a chance to hit pause and come back. What makes this 0 is where I want to start, which would be a 3. Working left or smaller values would be 2, 1. Working right or larger values would be 4, 5. Now, there's nothing magic about 5 points. That's just what I kind of like because it gives me a good look at my graph. If I just plot these two, I don't know, it might be an absolute value looking function. But by plotting this 3rd and 4th point or 4th and 5th point, it kind of helps show me the shape or the curve of my graph. So that's why I do 5 points. Okay, plugging in 3, 3 minus 3 is 0, 0 squared is 0, minus 4 is a negative 4. You should notice some similarities. The negative 1 matched up, the negative 4 matched up. That's not a coincidence. Plug in 2. 2 minus 3 is a negative 1. Negative 1 squared is a positive 1. Minus 4 is a negative 3. Putting in positive 1, I get negative 2. Negative 2 squared is a positive 4. Positive 4 squared is 0. My pattern repeats down here. Plotting the points when x is a positive 3, 1, 2, 3, 1, 2, 3, 4. When x is a positive 2, y is a negative 3. When x is a positive 4, y is a negative 3. When x is a positive 1, y is 0. When x is a positive 5, y is 0. Same exact shape. Okay, we got to do somewhere we change the shape. Okay, let's give it a new page here. Let's start over. Get my grid back up, or my graph back up there. Y equals 2 times, made a little tweak there. 2 times x squared plus 1. I'm going to do something else. We're going to make a negative 2. All right, so that's what we got. My thought process does not change. I'm going to plug in values for x that make this 0 and go left and right. Even though this is not just a 1 like it was before, right? Over here. Sorry, wrong place. Over here, there was no number sitting in front of here. That doesn't matter. The thought process is the same if there is a number sitting there. So I'm going to start at 1 and go left. So I get 0 and negative 1. I get 2 and 3. Hit pause and finish. All right, hopefully you're back. When x is a positive 1 minus 1 is 0. 0 squared is 0. Times a negative 2 is 0. Plus 4, oh, it did it again. It is the same number as right here. Once again, not a coincidence. Okay, when x is 0. 0 minus 1 is a negative 1. -1 squared is a positive 1. Notice I'm following PEMDAS. Order of operations matters. Parentheses, exponents, okay? So I'm doing the parentheses, then I'm doing the exponent. So -1 squared is a positive 1. Multiplication times a -2 is a -2. Plus 4 is a positive 2. My pattern has to repeat down here. When x is a -1, -1 minus 1 is a -2. -2 squared is a positive 4. Positive 4 times a -2 is a -8. And a -8 plus 4 is a -4. Just want to double check. -1 minus 1 is a -2. -2 squared is a positive 4. Positive 4 times a -2 is a -8. Plus 4 is -8. So my next thing then is I want to plug in or plot my points. When x is 1, y is 4. 1, 2, 3, 4. When x is 0, y is 2. When x is 2, y is 2. When x is a -1, y is a -4 and a -4. And so notice this one is quite a bit steeper. Whoops, almost missed it. This one is quite a bit steeper, narrower, I missed that one, than the other one. Okay, why? Next question is, why is it upside down? So it's upside down because of the negative. See if I can talk and draw at the same time. I cannot. It's upside down because of the negative, and it's steeper because of the 2. Okay? Hopefully when you draw on paper and not on a tablet, it's easier. Okay, so it's steeper because of the 2, or narrower, and it's upside down because of the negative sign. Okay. Let's do one more. Hit pause, give it a try. Okay, hopefully you're back. Plugging in -2. Going left, I get -3. Get -4, I get -1, and I get 0. -2 plus 2 is 0. 0 squared is 4, times 0 is 0, and once again, that -3 shows up. -3 plus 2 is a -1. -1 squared is a positive 1. 1 times a third is a third. -3 is a -2 and 2/3. Plug in 4, -4 plus 2 is a -2. -2 squared is a positive 4. Times 1/3 is 4/3. -3 is a -1 and 2/3. Let me double check that. 4/3, -1. Yep. And you can use a calculator on the test. You can use a calculator on the homework. So you can plug all that mess in. Make sure I did my math correctly. I don't have a calculator sitting in front of me. Yeah, I think my numbers look good. Plug my points in. When x is a -2, or plot my points. When x is a -2, y is a -3. When x is -3, y is -2 and 2/3. So we're down here. And when it's a -1, we're down here. When x is 0, we are at -1 and 2/3. So we're sitting right there. And reflects over to right there. Notice my graph is right side up because it's positive, but how much wider it is. Super wide because of the 1/3. Okay? All right. I think that's probably enough for, I'll do one more. I'll make a new page. We'll do one more. y equals 1/2 x plus 4 squared. Okay, hit pause, give it a try. Okay, hopefully we're back. Plugging in -4. My y value, I've done this enough. We've done this enough. We know it's a -5. So now I'm going to -5, -6, -3, -2. Plugging in a -5 plus 4 is a -1, squared is a +1. Times a half is a half, -5, -4.5. And this one has to be a -4.5. Plugging in -6, I get -2. Squared is a +4. Half of 4 is 2. -5 is a -3. Same thing, plugging in 2. Oh, I can't add. No, that's right. Negative. Oh, I can't add. Glad I caught myself. Hopefully you caught me. -6. Wait a minute. Now I'm second guessing myself. It's too early in the morning. -6 plus 4 is a -2. -2 squared is a +4. Half of 4 is 2. I was right. -3. Second guessed myself. And that's the same. All right. -4. 1, 2, 3, 4. 1, 2, 3, 4, 5. When x is a -6, y is a -3. Oh, sorry, -5 is -4.5. And -3 is -4.5. Here we go. -6 is -3. And -3. And notice it's wide, but not as wide as the 1/3. But it is wider than just the y equals x squared. Okay. That's enough for quadratics. Let's go to absolute value. And the thought process is going to be exactly the same. My shape is going to be different, but my thought process is exactly the same. So I got to do something just because it's the first one for this recording. Let's just do y equals absolute value of x. And I'm going to pick the same values that I've been looking at. Wow. The same values that I've been looking at in the quadratic. So we'll do a -2, -1, 0, 1, 2. And I'll plug them in. Absolute value of a -2 is a +2. Absolute value of a -1 is a +1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Plugging those points or plotting those points, I get 0, 0. +1, -1 are both at 1. +2, -2 are both at 2. And I get not a parabola shape. I get a straight line on both sides. I get a V shape, not a U shape. Not a parabola shape. I get a V, an absolute V. Okay, so now I'm going to do the exact same thought process. If you think you got it, go ahead and hit pause. Don't wait for my explanation of where to start. So what makes this 0? A +1. And I'm going to go from there. Now if you need to hit pause and go, you can. Left of 1 is 0 and -1. Right of 1 is 2 and 3. Plugging in 1, I get 0 plus 3. Oh, it happened again. I still get that same relationship. Whatever's out here comes right here at the vertex. Okay, when x is 0, y is -1. Absolute value of 1 is 4. -1 minus 1 is a -2. Absolute value is a +2 plus 3 is 5. Now, looking at this pattern, these numbers should just be the same thing. 2 minus 1 is 1 plus 3. It is 4, and it is 5. So my new graph starts here at 1, and 3. When x is 0, y is 4. When x is 1, y is 4. When x is when x is negative 1, y is 5. And 3, y is 5. Same v, just shifted. Right 1 and up 3. Do another one. We can fit it right here on the graph. Y equals negative absolute value of x plus 1 minus 2. Hit pause. Give it a try. Okay. Hopefully you're back by now. So I got negative 1. Going to the left, I get negative 2. I get negative 3. Going to the right, I get 0 and 1. Now, before I do my table, I'm going to graph this simply looking at the shape and the shift. The shape and the shift. So this graph, notice x minus 1. What did it do to my graph? X minus 1 caused me to go right 1. I had to start at 1 and go out from there instead of starting at 0 and going out from there. My y value started at 3 instead of starting at 0. But it still went the same pattern. I went left 1 and up 1. From 3 to 4 is up 1, just like I did right here. I went right 1 and up 1, just like I did here. So I'm going to graph this shift. I'm going to find my vertex. Negative 1, negative 2. Now my pattern should be the same. Right 1 and up 1, except for this negative sign. Think what this did to the quadratic. It flipped it over. So I'll do the exact same thing. Left 1, and instead of up, I'll go down. Right 1 and down 1. Right 2, down 2, left 2, down 2. The same V flipped over and shifted. If you want to make a table, let's just double check. Negative 1 plus 1 is 0. 0 times a negative 1 is a negative, 0. And that is still my negative 2. Putting in 0, 0 plus 1 is 1. Times a negative 1 is a negative 1. Minus 2 is a negative 3. Same up here. Plugging in a negative 3, I get negative 2. Absolute value is a positive 2. Negative makes it a negative 2. Minus 2 is a negative 4. And if you plot those points, you notice they are the exact same graph as what we graphed up here. Okay, one more. What if we throw a number in front? Go ahead, hit pause, give it a try. Let me give myself some room here. All right. Let's grab this whole thing and just slide it up. All right. So I'm going to make my little table. I'm going to get rid of my graph stuff also. I should have just made a new page. Oh well. All right. Starting at negative 2. Right? What makes the inside 0? My y value, I already know. Negative 3. We've done this a lot now. Go left. Negative 3. Negative 4. Go right. Negative 1. 0. Putting in a negative 3. Negative 3 plus 2 is a negative 1. Absolute value makes it a positive 1. Times 2 makes it a positive 2. Minus 3 makes it a negative 1. Repeats over here. When x is a negative 4, negative 4 plus 2 is a negative 2. Absolute value makes it a positive 2. Times 2 is a positive 4. Minus 3 is a positive 1. And it repeats over here. Plotting my points, starting right here. When x is a negative 2, y is a negative 3. When x is a negative 3, y is a negative 1. And when x is a negative 1, y is a negative 1. When x is 0, y is 1. When x is a negative 4, y is 1. Notice I still get my v. But notice the slope is the number in front of the absolute value. My slope is 2 over 1, and I really do mean slope as in the rise or run from a linear equation. So my rise is 2, my run is 1, my rise is 2, my run is 1 because of that right there. And the same in the other direction. The rise is 2, the run is 1. But the difference when in an absolute value is this bottom number, you go both left and right. So I was wrong. I changed my mind. I have to do one more. So what if I had some weird thing, and I'm going to show you the power of not having to do tables and just graph it based upon the pattern that we know. I just did 3. Okay, so what, I'm not going to make a table. My graph shifts right 2 and down 1. My graph shifts right 2 and down 1. There is the bottom of my V. Had this been a negative up here, this would be the top of my V. Okay, from that V, I'm simply going to graph the slope just like I did here, but now I'll do it here. So now my rise is 2, back from linear stuff. My slope, my rise over run. Rise is 2, run is 3 in both directions. So I'll go rise of 2, run of 3 to the right, and a run of 3 to the left. Rise of 2, a run of 3 in both directions. And plot my, or connect my dots. And whoops, and it really is that easy. Know your shifts, know your slope, and plot the points. Or, if you don't like that, know your value for x that makes the inside 0, start there, work your way out, and just make a table of values. Okay, that's been way longer than I thought. That was a half hour. That's enough practice problems. If you still have questions, let me know, and we'll see what we can do.